Hello, we're Team Arabidopsis from Open Window School in Bellevue, Washington. Our experiment is Arabidopsis thaliana in Martian soil simulant. I'm Vivian.
I'm Catherine.
And I'm Subi.
And this is our project.
Why we chose our project. There were many reasons why we chose our project, but the main one was because all the recent news about wanting to colonize Mars. Mars, when you get there, you're going to need food, and having to carry all your food from Earth is very expensive and takes a lot of time. So when they get to Mars, it would be a whole lot easier if you could just grow your own food. But growing food on Mars will be very hard because the soil and the gravity is very different from Earth's. For the soil, we're using a soil scraped from a volcano in Hawaii, which has about the same chemical makeup as the soil on Mars. And for the gravity, that's why we're trying to send it up to the ISS, because Mars's gravity is about 1/3 of Earth's, and we can't simulate a lower gravity on Earth for a long period of time, so sending it up to the ISS will let us do that.
In a similar to Martian environment, how will Arabidopsis thaliana germinate, if at all? Arabidopsis thaliana is a commonly used mustard seed for scientific studies, but surprisingly, no one has tested it in an environment like this. In similar experiments, however, such as in Earth soil in microgravity, the Arabidopsis has germinated very well. We will halt the growth of the specimen before 2 weeks because it has a very quick germination process, and so it would have died off by the time it had come back to Earth. One of our struggles with having all of these tests and the germination was that our first sterilization procedure killed the seed, so we had to have another one. We believe that based on the previous studies, it will do reasonably well.
Experiment design and analysis procedure. We have a type 3 FME, which has 3 different volumes. In our first volume, we will have 2.5 milliliters of Martian soil simulant and 100 seeds of Arabidopsis thaliana. In our second volume, we have 2.5 milliliters of sterilized water, which will jumpstart the germination of the seeds. And in our third volume, we have 2.5 milliliters of 20% natural neutral buffered formalin, which will halt the growth at the end of our experiment. For our procedure, we will count how many seeds there are, how many of them germinate. We will also look at the size of and shapes of the roots, stems, and leaves. We will also check the lengths of the stems and the volume of the stems overall. And of course, we will compare them to the ground truth experiment.
Speaking of ground truth experiment results, we haven't done our official ground truth experiment yet since we're going up in November, but we have done many experiments in the process of finding the best soil to water ratio and sterilization procedure. Although the plant is very hardy and difficult to kill, the seeds are really are very delicate and quite easy to kill, actually. So after a lot of trials, we have an average of 34 out of 50 very small seeds, which is just how Arabidopsis is, in 1 milliliter of water and 1 milliliter of soil.
Our hypothesis of what will happen in space. In space, we think that when the FME is mixed to start the germination process, that the soil and the water might separate, leaving some seeds without the correct ratio of soil and water to grow. And that might cause them not to grow. And then if they do germinate, we think that because of the Martian soil, which is a different kind of soil, that they might grow bigger or smaller or maybe just not grow at all.
Acknowledgments. Now, I would like to acknowledge all of the family members and parents for helping us, and also Mrs. Gifford, Mr. Preston, and our other teachers for helping us out. We would also like to thank Dr. Rutherford in particular because of all the scientific knowledge he gave us about Arabidopsis. And of course, all of the SSEP people who helped us along the way. And the review board. Thank you.
Any questions?
Hello, I'm Ross Rutherford from Seattle again. And I'd like to ask why you chose Arabidopsis seeds in particular for your experiment.
We chose Arabidopsis because there is a lot of scientific knowledge about it already, and so if we had any problems, there's a lot of knowledge, particularly Patrick Masson from the University of, I believe it is Minnesota, and Dr. Robert Rutherford, who is my dad, who did a lot of research on Arabidopsis. And it's also a very small seed, meaning that you can have a lot of them in a tube.
Seems prudent. Thank you.
Hi, I'm Audrey from Seattle. So I'm guessing you people probably saw the movie The Martian. Yeah. So in The
Yeah.
Martian, when they were growing potatoes in the soil, or when he was growing potatoes in the soil on Mars, he made a big deal of needing bacteria to grow seeds. Did you guys?
Not
research
really,
that?
no. Because when we did our experiments, the non-sterilized Martian soil, it grew the seeds very, very well, and they didn't need any dirt, any like bacteria. And then even in the sterilized one, that one also grew very well. And so you don't need bacteria for the plants to grow in the Martian soil.
And I believe the bacteria was because he had to use human feces instead of soil, and since we do have soil that is oxygenated since it's been on Earth, I think that's fine.
Nice, thank you.
Hi, I'm Bess and I'm from Seattle. Why did you choose volcano dirt from Hawaii?
Well, because since we didn't have any actual Mars soil anywhere, instead we decided on a compound that was very similar, like a Simulant, for example, and we couldn't find any other but ones that were collected from that volcano. So, yeah.
So the dirt from the volcano, it has the same chemical makeup, about the same chemical makeup as the dirt on Mars. And we know this from the rovers because they've done many tests. And so when we saw that the volcano, we could get dirt from it, we were very excited so that we could use a close to what the Martian soil would be.
Thank you.
I'm Emma from Burleson. If in outer space, where the International Space Station is, if there's less gravity there than in Mars, why do you think it'll grow in there if you're trying to see if it'll grow in Mars?
Well, the gravity on the International Space Station is a lot closer to Mars than the Earth gravity is, because Mars's gravity is about a third of Earth's, and Earth's gravity is about 3 times Mars. And since the International Space Station has no gravity, it's closer to Mars's gravity than Earth's.
Okay, thank you.
But if we had the chance, we probably would have used a centrifuge to keep it at 1/3 gravity.
Thank you.
Like a centrifuge in the ISS. So like with no gravity, then make it more gravity.
I'm Carolyn from Seattle, and do you know the name of the volcano you got the Martian soil simulant from?
Well, I can tell you this. I may not know where it is from, but you can search it up online.
I used to know, and then I forgot.
I'm Christopher from West Vancouver, BC. How are you guys going to get the dirt from the volcano?
We already have it from this online site called Orbitech. They give you science-y stuff, and they get it from the volcano, not us.
Yeah, you order it online, like from Amazon, and then it comes in a big bag.
Emma from Burleson, the other Emma though. So when he asked you why you used the seeds, you said because you knew more things about them and you had more knowledge on them. But why didn't you want to choose something that you had less knowledge on, to where you could experiment with it and find out a new result and see how it reacted?
Well, we chose it because there's a lot of knowledge on it that's just general scientific knowledge, but there isn't any knowledge that's like this in this type of situation. So if we run into a problem, we can have help, but we're still covering the scientific ground and pushing the envelope.
Okay.
Also, the seeds are really small, so we can have an actual percentage of germination that's accurate out of 100.
Okay, thank you.
My name's Bella. I'm from Burleson. Okay, so between the volcano soil, whatever that is, and Mars soil, what is the biggest difference except the fact that it's not from Mars?
We don't really know, but we just know that's very close, just in like the chemicals and the elements in it. There's probably some missing, but it's as close as we can get.
Yeah, chemically it's very, very similar. And the biggest difference is that it's on Earth, and so it has oxygen, which is a pretty big thing, but most people overlook it.
Oh, okay, thank you.
Hi, my name is Griffin Edward. I'm from Westcott Elementary in West Vancouver. What other ideas did you have before you came up with this one?
We had just a ton of ideas in the first day. I can't remember any of them. But our biggest idea was actually, until we got to the step 1 review board, we were going to compare Arabidopsis and soybeans. And we did a lot of research on osteoporosis and astronauts in microgravity because it's the deterioration of the bones. And then the review board said it's too complicated, you should cut out the soybeans, so we did.
Okay, thank you for all the great questions.